Yes, I know. I am missing some facial hair, but let's not talk about that. Let's talk about something that matters. Well, that matters. I do want that to grow back as soon as possible because I'm looking like I'm 12. But let's talk about software engineering. A common theme for every developer is to integrate with a third-party provider, whether that is a payment system, an email system, a subscription system. It doesn't really matter. Sometimes you have to make calls to something you do not own. And believe it or not, although that is a common thing, that is complicated. It has several nuances that we have to take into account. For example, how do you write tasks for such an integration? Let's say that you're talking to a payment provider such as Stripe. Do you just run your tasks as usual and hit Stripe server? Well, that kind of works, but that also slows down the tasks. So a common solution is to mock those in your tasks. You create a mock during runtime that swaps the real object, the real Stripe implementation with a mocked implementation and use a mock framework to assert that some calls have been made, etc. On this video, I want to provide another, or rather show a different way of handling those using what we call fake objects. They are very similar to mocks, but they have many benefits in my opinion. So let's jump into the code and show a few examples and how I would do a third-party integration nowadays. All right, so let's take a look. We have a subscribe to active campaign controller, which calls an active campaign service. We're just passing an email. And then we have the active campaign service, which doesn't really do anything. I'm just simulating a slow request to a third-party provider. And then we have a very simple test. We are mocking the active campaign service. We're making a post request. And if you've ever worked with Laravel, you know that this is going to swap the implementation on the container. If you have not worked with Laravel, this is just syntax sugar to creating a mocked object using mockery and swapping that within the container. So if I remove this and I run the tasks, they pass, but they take a while, as you've seen. If I mock this, however, we're not going to hit the real implementation, and therefore it isn't going to take such a long time. In the mock, I also added some expectations. So I'm expecting Mateus at mateusguimarães.com. And if I pass something else, like this, for example, the task is going to fail. So that works, but it has some defects, I would say, in my opinion. First, mocked tasks are really hard to refactor. Secondly, this is just a sample, so it's not that big. But what you see in production code bases is that lots of tasks have, well, most of their task cases are composed of mock expectations. So half your tasks are mocks and the other half is the actual task. And that's not good. They're easy to break, they're hard to refactor, and sometimes they're not really tasking anything. It's really easy to lose hand with mocking and just tasks that you pass, that you wrote something as you expected to. Let's look at a different way of handling this, which gives you type safety, makes your tasks smaller, and it's much easier to refactor. So first, let's get rid of this. Let's run the task. As you see, 500 milliseconds, that's because we're hitting the real implementation. And we did not want to do that. We want to test the real implementation in isolation. And for every task, well, for every task of every functionality that uses the real implementation, we want to use a fake one. A mock is an example of a way to fake an implementation, but let's look into fake objects. So we have a class with the real implementation. What we want to do is to create a class with a fake implementation. If you've ever worked with Laravel, we have those already. We have the event fake, which is the fake implementation for the event dispatcher. You have the bus fake, which is the fake implementation for the bus dispatcher, etc., etc., etc. They're all real classes. We don't use mocks for those. So let's do that. Let's create a new class called, we're going to call it in-memory active campaign service. And we're going to add the same method, a subscribe method, and we're going to expect an email. We did not return anything. Now, on this fake implementation, instead of actually calling active campaign, we can just store this in an internal array. So let's create that. We're going to call it subscriptions, and it is going to be an empty array for now. Let's type hint this. Okay. Now, within the method, we're not really going to do anything. We're just going to push the value into that array. Perfect. Now, within our task, we're going to swap what we have in the container. Remember, on the controller, we are fetching this active campaign service from within the container. But if you were to unit test this, you could just pass, well, I wouldn't unit test a controller, but if you were to unit test a different piece of your application, you could pass that as an argument. So let's do this in a way, just so folks who are not into Laravel can understand this. I'm going to create an in-memory active campaign service. Thank you, Copilot. I'm going to import this. There we go. We have our in-memory implementation. Now, since this is calling the kernel behind the scenes, taking a request and whatnot, we have to swap what we have in the container. So let's go into the container, and we're going to swap our instance of active campaign service for our instance of in-memory active campaign. Let's see if this works. And it won't, but let's try this. Well, it failed. Let's see what failed. So argument 1 must be of type active campaign service, and we got in-memory active campaign service. So what we could do here, and that's not the correct way, is to just extend active campaign service, but that's a terrible thing to do. If we run this, it is going to pass, but this is an awful way to handle this because now you're accepting multiple types. You're accepting active campaign service and its subtypes. Let's instead do this properly. What we can do is I'm going to go into active campaign service and I'm going to rename this into HTTP active campaign service. Now I am going to create an interface, and the interface is going to be called active campaign service. It's supposed to be an interface. There we go. And now we can add the subscribe method. Cool. Now let's go into our services and implement the interface. What we did here is we are now adhering to a contract. So instead of type hinting in our controller, the HTTP active campaign service, which is our concrete implementation, we can just expect any kind of active campaign service, and we're just going to follow the contract. So at the type system level, we know what we want to expect. That is, we want to expect a class that implements that interface. So it has the subscribe method. We have the guarantee by the type system. It's impossible to call subscribe method on an object that doesn't have that because we are enforcing that. And we can pass any variations of those. We can pass an HTTP active campaign service. We can pass an in-memory active campaign service, etc. Let's rerun our tests. Okay, still failing. Let's see what's up. We got a 500. Target active campaign service is not instinctable. Okay, that's cool. And that's because we need to fix this. We are swapping the concrete implementation. So let's change that for our interface. Let's rerun this. Okay, now it's passing. The test still looks the same. We haven't really asserted that we've passed the correct email or that we've created a subscription. So we can do that now. Just like with event fake and bus fake, we can call methods within this in-memory active campaign. For example, we could say in-memory active campaign, assert subscribed, and we can pass an email. So let's pass my email. Let's run this, and it is going to fail because we don't have that method. Yep, it's failing. Let's go here and create this method. This shouldn't return anything. So first, let's see how do we know if someone has subscribed? Well, we have that array of subscriptions. So let's create a variable called is subscribed, or rather has subscribed. And we can say in array, let's rename this to email. There we go. And let's dump and die this. Okay, true, that's what we expect. But we want to assert this. So we can call PHP unit directly. If we say PHP unit assert, that's what we want. And then we can say assert true. There we go. Thank you, Copilot. You're doing my job. And then we can even go with a proper error message. The expected email, and we can pass the email was not subscribed. There we go. Thank you, Copilot, again. So let's rerun this. There we go. It's passing. And if we go here and we change the email that we expected, for example, to this one, now we get a proper error. The expected email was not subscribed. So now we have a fake object with a real method for us to call that follows a contract. So we have guarantees at the type system level that every object that gets passed to this controller is going to follow that contract, and we can just swap them in the tests. Now, one funny thing though is, although we have this, if we remove this, the test is not going to run, it is going to fail. And that's because an interface is not instantiatable by the container. So whenever you're expecting an interface and you're using the Laravel container or any sort of container to fetch it for you, you need to make sure it is bound to the container. What I like to do is to first create a task. So let's create a task for HTTP Active Campaign Service task. There we go. And this is where we would test our actual Active Campaign implementation. This is where we could hit Active Campaign and make sure that it works properly. So you have a single source of truth. I would say you have a place where you can test the actual implementation. And in every other task, you can just use the in-memory implementation. What I would do as well is I would create an Active Campaign Service task, and I would use this task to basically ensure that I have the correct implementation bound to the container by default. In this case, we want to make sure that the HTTP implementation is bound to the container. So that's a really simple task. So we can say something like, let's add our task annotation, and we can say it is bound to the container. And we can simply say that we expect something to be an instance of, and in this case, we want HTTP Active Campaign Service, and then we're just going to grab something from the container. We're going to make an object from within the container, and we're going to pass our interface like this. There we go. This task is going to fail. Okay, cool. Let's go into our app service provider just so we can register this. So let's go into the register method and say that we want to bind Active Campaign Service, and we just want to return a new HTTP Active Campaign Service. There we go. Let's run our tasks, and now they're passing. So now we have a task to guarantee that we have the correct implementation bound by default. And then within our tasks that use the Active Campaign functionality, we can just use an in-memory implementation instead of a fake. So this is easy to refactor because we have actual objects, and PHP Storm or any IDE will be able to refactor this easily. It's easy to find where it's being used. You don't have to worry about testing functionality that doesn't work, which is something that happens quite frequently with mocks, since you can just tell it to expect anything you want, and you're actually testing behavior. Now, the trick is, I would also add a test for this. I want to make sure that this works properly. So even the in-memory implementation would have a test as well. And now whenever you want to not hit Active Campaign, you can just use this fake implementation. If you want some syntax trigger, what you can do as well is you can add a static method here. Let's call it activate or something like that, or swap, whatever you want. And you can replace this within the container. You can do something like app instance, and we want to replace the contract with this fake implementation. Now we also have to return this object because we're going to use it to make assertions. So this is actually going to return an instance of itself, and we can call this self. This is not a public function, this is a public static function. So we can say that self is going to be new static, and then you can just return self. So we are swapping something within container. We're swapping the Active Campaign Service key in the container for a new instance of the in-memory implementation. And we actually, let's put this outside. So we're instantiating this, and here we would return a closure with the object. Actually, I think you can just return the object here. Can't you? I'm not sure. Let's try this. So let's return self. Let's run our tests. Okay, they're passing. Let's go into our task. And instead of this, let's just call swap. So since it returns an instance of itself, we can call activate, and we shouldn't need this. Let's see what happens. Yeah, there we go. So now we have some syntax trigger to swap this within the container and also return an instance of itself, because we're going to use it later. We need to make sure that we have the same object. If we were to grab a different instance of the in-memory implementation, you wouldn't have the subscriptions registered. So that just makes that a little bit easier. Most purists are going to discriminate me for doing this, but I do this. I think it's a very nice syntax trigger. But anyway, that's pretty much it. So as you see, it's not a lot of trouble. You get very clear boundaries. It makes your code much easier to test, and you don't have to worry about refactors or testing something that doesn't exist. And that's it. very quick video, very easy, very fast to implement. So I hope that's something that helped you somehow. And I think this is a tip that you can implement starting tomorrow. It's a common thing. This is not anything new to software development. It's just something that sometimes we have all these tools and marking tools and whatnot, and we just use them by default when you can just create another object and create an interface and use polymorphism to handle this problem. So let me know if this video was helpful. If you guys like this type of video, leave some comments, that kind of thing. I really appreciate that. Leave a like in the video. And if you have any sort of ideas for content, do let me know either here on YouTube or Twitter. Doesn't really matter. I would be more than happy to hear any criticisms, suggestions, anything that you want. See you guys on the new video. Not the new video. This is the new video. See you guys on the next video. Bye bye. Have a good one.